So what is cryptography? Like, we are talking about cryptocurrencies, we are talking about hashing and mining. But first, let's understand what is cryptography. Cryptography is mathematically linked. So in cryptography, uh, whatever we do today, we open up Facebook, we are using Zoom. Here, our data is secure by certain sort of cryptography. Now, Zoom, Facebook, all these websites use SHA-256, and the Bitcoin blockchain also leverages that. I'll show you a small working example of hashing. So if I input something here, so this is the hash, SHA-256 to SHA-256 hash of it. If I change just one single letter as well, the entire hash changes. So this is and these hashes aren't reversible. So the hash of Smith is this big string, but there is no way to reverse it. There's no way to find out that this hash reverses back to Smith. Now this is the beauty of cryptography. All of this is mathematical. You can go ahead and read books on how cryptography works. So this is only one way. Similarly, we have public and private key cryptography. So the address on which you receive funds on any blockchain, let's say Bitcoin, Ethereum, Monero, this address is your public key. You can share it with anybody in order to receive funds. Now the private key is mathematically linked to this public key, and only you and you can spend your funds by signing the transaction. We'll see an example on that in a while. Okay. So, asymmetrical encryption that we just talked about, there's a public key and there's a private key. So Bitcoin and Ethereum uses the same algorithm, spec 256. So this is a small example of public and private key. This is like a public key which you can share with anybody, and this is a private key which you shouldn't share with anybody. So let's say that we sign a message. Let's say, hey, this is Smith. We signed this message. So this creates an output. There's do not put a lot of effort into understanding this. This is just a basic example. So now this message is mathematically signed by the private key. Now, if somebody wants to verify that, okay, just 1 minute. Let's say we copy the public key. Okay, and this is the signature output that we received. Now, if we want to verify the signature, we don't even need the private key. We just enter what the signature that we received earlier. We just have the public key and we have the message, and it can be mathematically proved just via the public key that, okay, I signed this message that, hey, this is Smith, using my private key without the other person knowing my private key. So this is how the public and private key cryptography works, and this is exactly how Bitcoin and Ethereum works. When you transact, you sign a message that, okay, I'm transferring 1 Bitcoin to somebody, and the miner or the nodes, they do not need to know your the private key. They just need to know your public key, and they can verify that okay, you are the rightful owner of this fund. So now this was about the Bitcoin blockchain.